Let's continue our topic motion along a straight line with uniform acceleration. So we will use equations of motion. So we were talking about motion under gravity. So when something is released, sometimes the initial velocity is zero. When it is released from top of the building, if it is released from balloon, then the velocity will not be zero. So let's talk about balloon. Ball is released from balloon which is going upward. Ball is released from balloon which is going upward with some velocity, constant velocity. Suppose the constant velocity of balloon is v naught. So suppose this is the basket and the balloon is attached with this basket, and there is a person standing on this basket. This person is holding a ball. Balloon is going upward with constant velocity v naught. Now at an instant, the height of the balloon above the ground is h. So this is the ground level and this is the initial level of ball. Initial level of ball. So you observe when the balloon is going upward, the person is also going upward, and the person holding the ball, that ball is also going upward. So what is the initial velocity of ball? Initial velocity of ball is v naught upward. Initial velocity of ball after it is released. Now this person will release the ball now. So initial velocity of the ball is upward. So the motion of the ball will be like this. It will it will go upward little bit, then it will come back. It will go upward, then it will come back, and it will hit the ground. It will hit the ground. So how much it is going upward? Suppose at point A the ball is released and the topmost point is B, then again it will come to A and it will hit the ground at C. When it is coming to A, its velocity will be v1 or v naught downward. At A, the velocity is v naught upward, and at A again, when it is returning, so this is going up, this is going up, and this is coming down or going down. So at A it is released, so velocity is upward, v naught, topmost point velocity 0, then it is coming back, it will come to same level again. At that level the velocity will be minus v naught, then it will hit the ground at C. So this is the ground level, this is the ground level. Suppose it is hitting the ground with velocity v2, so we can find v2 also. A to B, let's find out how much time it will take, and A to C, how much time it will take. A to C, how much time it will take, we can find using height. So height is given, height of A is given as h. So let's find time taken from A to C during downward motion. So for A to C downward motion, the ball is released when the balloon is at height h. Then it will go upward, then again it will come back to the same level. So from that instant to the instant of hitting the ground, how much time it will take? We'll use S is equal to ut plus half at square. So that will be equal to minus h is equal to minus v naught t minus g by 2 into t square. So using this equation we can find how much time it will take from A to C. This is one method. Another method is also there. You can consider A to C total time. Then for A to C total time, it is going up to B, then B to C it is coming. So displacement will be minus h, but U will be plus V naught. Acceleration is minus g into t square. So this is the total time of flight. Total time of flight. If you use this, the problem with this is it is a quadratic equation. So sometimes quadratic equation solving takes more time. So we have one more another method. What is that another method? I will tell you. We will find V2 first. How to find V2? We will use V square minus U square is equal to 2AS. So when it is going from A to C, the final velocity is V2 square, initial velocity is V naught. So U square will be V naught square. 2A, A is minus G, S is minus H. So V2 square minus V naught square is equal to 2GH. So V2 square will be V naught square plus 2GH. So we can say V2 is equal to minus square root of V naught square plus 2GH. So this is the velocity of strike. Velocity of strike. Once you have velocity of strike, we can find all the times, how much time it is taking to go from A to B. We will use V is equal to U plus AT. Then again B to A, it will take same time. And then A to C, again we can use V is equal to U plus AT. And V2 we got. So V2 we got as V2 is equal to minus square root of V naught square plus 2GH. So let's use this formula in solving this type of question. So suppose the initial height of the balloon is balloon height is 10 meter. When it is going upward with constant velocity, say 20 meter per second. A ball is released from it. Now first question, find velocity of strike. So we have the direct formula for that now. The velocity of a strike will be minus square root of this formula, minus square root of V naught square plus 2gh that is equal to square root of V naught square. V naught is the initial velocity of the balloon, which is equal to 20, and the height of balloon when the ball is released is 10 meter. So this is minus square root of 400 plus 200. So minus square root of 600, or we can say minus 10 root 6 meter per second. So this is the velocity of strike. Let's find what is the time of flight. So to find the time of flight, we can use V is equal to U plus AT. Find time to hit ground by ball. So V is equal to U plus AT. Now V we got minus 10 root 6. U is V naught. A is minus G into T. So minus 10 root 6 is equal to V naught, which is 20. Then minus 10T divided by 10. So minus root 6 is equal to 2 minus T. So we have T is equal to 2 plus root 6. So this much time it will take to hit the ground, and root 6 can be written as root 2 into root 3. So approximate answer will get 2 plus 1.4 into 1.7. If you solve this, we'll get time to hit the ground. And next question, the maximum height covered or reached by the ball. Maximum height reached by ball. So initial velocity of the ball is 20 meter per second. So it will go to the topmost point where the velocity will become 0. Let's calculate this height. So this height, we know the formula. If something is thrown with velocity u, so 0 square minus u square is equal to 2 into minus g into h. So u square is equal to 2gh. So h is equal to u square by 2g. So it is thrown with velocity 20. So this height will be, let's suppose this height is h1. So h1 is equal to u square by 2g. So that is equal to 400 by 20. That is equal to 20 meter. So further, how much high it will go? 20 meter. And the ball was released when already it was at height of 10 meter. So the maximum height reached by the ball is 30 meter. And one more question in this question, fourth question. Find distance covered by ball after it is released from balloon or from the instant it is released from balloon till the instant it will hit the ground, till the instant it will hit the ground. So now we have found the maximum height reached from the moment it is released from balloon. The further how much it is going, we have found that it is 20 meter. Then it will come down 20 meter, and further it will go 10 meter. So total distance will be 20 plus 20 plus 10. 20 plus 20 plus 10, so that is equal to 50 meter.